Welcome to Lecture 7, Functional Programming. Chapter 6, Part 1, Functional Programming, the basic concept of functional programming. Objective, concept of functional programming. So in this chapter, we are going to go over the basic concept of functional programming, including the pure function, recursion, referential transparency, function as first-class citizen, and can be higher order. And we talk about the first-class citizen and higher order function, and also immutable variables. Overview. Programming paradigm. We already introduced the imperative programming paradigm, object-oriented programming paradigm. And today we are going to talk about one declarative paradigm, that is functional programming paradigm. And Python support procedural programming, object-oriented programming, and functional programming. So Python is a good language for us to cover different programming paradigm. That's why we pick it as our pilot language in this course. Okay, here we have different programming paradigm and its related language. So you can look at it. Functional programming language is closer to people's mathematical understanding because it's based on lambda expression, lambda calculus. And humans actually tend to deal with some math. And in internal machine, they deal with the instructions. So on the machine side, imperative programming is closer. And there are people, they try to build Lisp machine in early 70s or 80s. There are people trying to build Lisp machine, but not very successful. And will there be a new lambda calculus-based machine or AI machine that purely supporting the functional programming? Maybe in the near future, there are some microprocessor that will be focused on this. But at this moment, people are working on the imperative programming machine and working on GPU for the AI. So the study of the functional programming machine has not been there yet. And there are hybrid languages such as Scala and F#. So functional programming is a programming paradigm in which we try to bind everything in pure mathematical function format. So we basically write program in function calling function way, and it is a declarative type of programming style. Its main focus is on what to solve, in contrast to imperative programming, where main focus is how to solve. So we actually apply things to things. That's called how to solve. We try to solve some problem. That's called how to solve. And we use expressions instead of statements. And a statement, excuse me, an expression is evaluated to produce value, whereas a statement is executed to assign value to. So basically, statement is this: A equals 3, and you assign this to this. Expression is A times 3. So that's different. You produce a value here. And this one trying to assign value to it. And those functions have some special feature discussed below. So here, why should we use a functional programming? Actually, number one is fewer. Number two, code simpler, usually mostly recursion, no side effect. Easy to parallelize. This portion is very important. Easy to parallelize. People still working on this because they are seeking the opportunity to parallelize the execution of the program. And functional programming seems to be supporting this better. And mathematical approvable. So not many ad hoc algorithm. We try to make sure that actually mathematical sound problem solving skill, and it has been around for a while. And actually, functional programming was used to AI first, and AI was has been there for quite a long time. Because there is no good machine support, so AI was not very successful before the year 2015. But recently, because of the advancement of the IC technology, and AI machine become more popular, and functional programming become more feasible, because right now a lot of CPU, GPU are supporting multi-threading, multi-core, and the parallelism seem to become a feasible way to do programming compared to 20 years ago when people just use CPU and single thread. Functional core concept, function-oriented expression rather than statement, algebraic type, pattern matching. Okay, these are few core concept. So basically, it's function calling function. You just try to design a lot of functions. That's called functional programming. So turn to know, number one, you must know about what is immutable data. Immutable data is something that you cannot change. You can create new object based on it, but you cannot change the content of the data. First-class functions. First-class functions are functions that can behave like first-class citizens in programming. That can be parameter, can be return value, can be function, can be anything that you use in your program, can be assigned as a variable. And recursion is to have function calling function itself. And tail optimization is a term for recursive program. Mapping, reducing, pipelining, currying, higher order functions, and lazy evaluation. These are different terms that you need to know in this course. So functional programming, including these different features: functional composition, immutability, currying, higher order function, refactoring, pure function, referential transparency. These are key ideas for functional programming, and we are going to discuss it one by one. And first-class functions, no side effect, lazy evaluation, statelessness. Statelessness means that not going to store the state. And immutable data, pure function. These are some features that functional programming are using. Okay, no side effect. First one, no side effect. Right-hand side, no side effect, because you have a function and you provide A and B into there, and it returns the sum A plus B. So there's no side effect. On the left-hand side, we do have another function called add. So you have sum actually put here, and in the computation, you do modify the sum. So there's a side effect. So pure function is right-hand side, that's pure function. That is function that has no side effect. We call it pure function. Higher order function. Higher order function is to pass function as parameter to another function. So here we pass the lambda expression, that's a function, into the map function. So basically this one is to apply x squared to each of the value y. Okay. So that's mapping to that, and you print it as squares. And this one is functional programming. So basically, your map function, you provide a lambda expression and a y into it, and you created a sequence called squares. So function and the data being fit into a function that's called map. You create another data. Okay, this is the I/O relationship of this functional programming. And left-hand side, it is imperative programming. So basically, there's a for loop, and we actually work on some data and then return to some data. So basically, it is a y input, and there's a return value being generated, and no function being used. It actually internal, the for loop will do it. No function being passed. Okay, higher order function filter. So this one is another one called filter. So filter will depend on the lambda expression as a filter function, and you're going to filter the x. Okay, and here you create random 10 numbers, and then you apply x for the testing of the of this one. If it actually is multiple of 2, we are going to multiply it by 5. Okay, and now we'll return to a value here. So mapping function is applying this multiply by 5 to the data that actually will be passing the filter. Okay, passing the filter. And that's the new data you actually obtain. So right hand side, we are higher order function. Left hand side is the traditional imperative programming. Higher order function, reduce. So reduce is here we have a f function. So we use that, apply that to this one and the sum of this one, sum of this one, and sum of this one. That's called reduction. So basically applying it to every element in the list. Okay. So there's a lambda expression, and we do reduce. Python 3.5, Python 3 and above do not provide the built-in function called reduce. So you have to import the function tool to do it. Python of older version do have built-in function of reduce. So you can provide reduce to x, and okay, x is a sequence. So this right-hand side function is similar to the left-hand side, using the built-in function of sum to sum the x. Okay, tail regression. Tail regression is a function that do nothing when it returns from the smaller case. So we have recursive function, and there is a base case. So base case returns something, that's okay. But the recursive formula portion, you get the return from the previous smaller case. You just forward it to the next level, and now we call it tail regression. If you need to do extra operation, then that's not tail regression. Tail regression means at the tail, the last statement, you only call the function and without extra operations. Partial function, consider a function of ABC. You may want to have a function of GBC, and then which is equivalent to F1BC. So basically set one of the value fixed, and that's called partial function. So here we have such a partial function. We have import function tool, and we have a log function. And log function do have message and subsystem. Okay, so if we set the server subsystem as server, and then we create a new function called servlog, and that servlog will be basically printing the message with the server called subsystem. So this one is like this. You do have a function called log, and log actually takes 2 parameters, and then you send it to the partial function, and it generates a new function called server log. And this server log function only takes one parameter, and we call this one partial function. And partial function is a function itself in functional tool in Python. Public in Python, it doesn't exist. It doesn't exist. Okay, so left hand side we do have a brain. So we have brain. Okay, for bands. I'm sorry, format bands. So we have bands, and we every time take one bands, and the bands country will be Canada, and Canada's band's name will be replaced each dot with empty string. So the name is a dot, we will take out the dots, okay? And then that we work on the name, and the names, the title will be set into the name itself. So basically, this is to operate a different thing. So let's look at bands. So bands, we have name, country. So all the country will be updated with Canada. Okay, and their name, each band's name. Okay, each band's name, it will be set by getting this name. Okay, this is the name, and the name is a stat. You will replace by empty string. So here this stat will be taken out. Okay, this one will be taken out. Then name's title. Then the title function. Okay, there's a title function. You get a name, and that name has a title function, and that will be assigned to your name data. Okay, this one is called pipelining. You operate several functions in pipeline. So right hand side we have Python. So we reduce the data using map and then reduce. Okay, and pipeline each. So they are functions you put into there. So basically, when we call it, you actually call one function called lambda, change the Canada for function, and then call one lambda function that replace the dot with space. And there's another one called a string title to with the name. Okay, string title with the name. So basically, you're applying function after function after function, and you keep applying them based on your lambda being applied. So lambda, you do map the function to the data. Okay, make the function to the data. Okay, make the function a is functions to the data. Okay, and that's one by one. You take in each one of the to them. Okay, and you do reduce. You do need to reduce, means that it apply to each simple one. The result of the first one will be applied to the input of the next one. Okay, so that's called pipelining. Pipelining can be using this reduce of the function to run it. Okay, but Python does not support the built-in or module for the pipelining. So functional programming has this different concept: first-class citizen, pure function, higher order function, racial transparency, writing functional API, functional chaining, functional composition, closure, currying, lazy evaluation. So right here, we already talk about this one. We talk about this one. We talk about this one. We talk about this one. Okay. And functional composition is simple. Okay. And we still have a few topics to talk about. Okay. So function, you may have a function that takes vector in, vector out. So it's data input, provide data. That's regular functions. Okay, and you can have input of a function and you provide vector, that's called functional. Okay, so you take function input and provide vectors, that's called functional. And you actually can take a vector input and generate a new function that's called function factory. And you may have a function taken in and you create another function as functional operator. So partial function is a functional operator because you take the function in and generate a new function. That's called function operator. So function can take data as input, data as output. Function can also take function as input, function as output. So basically, there are 4 different combinations of the function in Python. So object-oriented programming versus the functional programming. So object-oriented programming is based on concept of objects instead of just functions and procedures. Object-oriented programming follow the imperative programming model. It does not support partial programming. Basic elements are object and methods, and object programming bring together data and its associated behavior in a single location. Functional programming, it emphasizes on the use of function calls as the primary programming construct. It tightly connected to declarative programming. It supports parallel programming. Okay, this is a main difference. object-oriented programming, you can use a multi-threading to do parallel processing, but it need extra function call. But functional programming, it can directly support a parallel programming. Okay, and basic elements are available on function, and OOP are objects and methods. And data and its associated behavior are considered different entity. Function and data are different entity, but objects can combine them. Okay, the key method here we have map, filter, reduce, and we also mentioned about partial function and pipelining. These are key feature we have. Okay, so you can map a function to the iterative object. You can filter, okay, the iterative function. So this one will get some extra object that's qualified. Okay, mapping will apply the function to each object and then get the result of that object. Reduce will get a function applying to the different object, and object A's result will be applied to object B and then keep going up. Okay, it's an N-to-1 relationship. Okay, and filter is N to M. Okay, and map is N to N. These are the dimensions. Okay, so so these are the functional programming. Section 2, functional programming in Python. So here let's look at what support the function Python has in functional programming. So what is functional programming? A pure function is a function whose output follows solely from its input value, and there's no side effect. In functional programming, a program consists entirely of evaluation of pure functions. So functional programming, we do not want the side effect. And computation proceeds by nested or composed function code without changing to the state and mutable data. So here, a function is taking the argument in, provide a return value, and no side effect, no side cost, and no side effect. Okay, no cost to change the function, no cost to affected by the function. And the functional programming paradigm is popular because it offers several advantages over other programming methods. Number one is higher level. Okay, it's more abstract, it's higher level. Number two is transparent. Okay, it's transparent, and it's a pure functional operation, so easier to do debugging. Can be parallelized and potentially faster, but right now we do not have the best functional programming machine to support it yet. Okay, many programming languages support some degree of functional programming. In some language, virtually all code follow functional programming. So Haskell is pure functional programming. Python, by contrast, does support functional programming, but contain features of other programming modules as well. So that's why we pick Python as a language to demonstrate this course contents. While it is true that in-depth definition function programming is somewhat complicated, the goal here isn't to present a rigorous definition, but show you what you can do by way of functional programming in Python. So here we just try to give you some idea of how functional programming can be done in Python. Okay, so to support functional programming, it's useful if a function is a given programming language has the two following ability. Number one, take another function as an argument, and to return another function to each code. So basically, if the programming language support first-class citizen, and that language should be able to support the functional programming. So Python plays nicely in both these respects. As you have learned in previous series, okay, Python's program is also an object. Okay, Python's functions are also object. First-class citizens. So in Python, functions are first-class citizens. That means functions have the same characteristic as value. So you can pass function as parameter. You can also return it as return value, and you can also assign a lambda expression to a function reference. So function in Python is an object. function in Python is an object. So it also is one kind of data. And it also is a module, and you can pass it to a function. So a function can be passed to a function, and it can also return a function. And you can also have an app, and then you assign some function to it. Okay, so can be a left-hand side value, can be a parameter, can be a return value. Of course, can be called. So this is so-called first-class citizens. Okay, in Python, functions are actually objects, can be assigned to a variable, assigned to a property of a object, and functional literals. You can write a function using anonymous function or number expression. Can be passed as function argument, can be returned as function result. So function as first-class citizen, we have citizen number one. So we have function called func. You print I am a function func, okay, and then you assign the function name to another name, and then you run another name, and you will create the same result as you call this one. So basically, func is an object reference, and you assign it to here, okay. Okay, next one. Function as first-class citizen. So the assignment of another name equals func. Unlike A, create a new reference to the function. Okay. So that's that. Okay. You can display a function to consoles with print function, include as an element in the composite data object. Okay, so right here, we do have a list. And inside the list, we have a function object. Okay, so function one, this one is actually a object. Okay, the objects one is this one, and objects one can be called, and you run this one, and then you can do d dot function. Okay, d dot function. D dot function. The function is actually a key, and you use that as a key, and you actually get the value. The value is 2. Okay, so function can also be a key or value in the dictionary. So function as first-class citizen. In this example, function appear in all same contexts as value. Okay, and the interpreter handle it just right. Okay, so note what you can or cannot do with any object in Python depends on some extent on context. So basically, it depends on how you use it and why you use it. Okay, and more usually functions can objects in Python you can use it in any way. Okay, in any way. Okay, function composition. So here we have an inner function called level print and function inner. Okay, and there's an outer function. You pass the function and run the function. So outer process the inner function, and you will call the inner function, and you will print out the data like this. That's called composition. So a function call another function, that's called composition. So here the call on line pass inner function as argument to the outer function, and write the outer function within the right outer function. The Python by the inner function as parameter, and you just run it. Okay, this is so-called function composition. Python provides a shortcut notation called decorator to facilitate wrapping one function inside another. We have taught you before in object-oriented programming. Callback function, when you pass a function to another function, that's called callback. Passing in function is sometimes referred to as a callback, because callback is inner function. Okay, so callback is an inner function. Callback maybe is event handler. Callback may be a processing handler function. So usually it's a parameter. So here we have animals. We can sort animals. Okay, so this function sorted. Okay, ordinarily you pass a list to the sorted and then sort them in lexical order. Okay, that's a function. And then sorted take an optional key. Okay, optional key. So optional key, you can use the length on it. Okay, so basically this one is a function that you apply to your animals. Okay, that way you apply to the animals, so that we can call this one length function as the callback function, not the handler function. Okay, that's the handler function to be used to do sorting. We can call the length function as handler function or callback function. Sorted can also take optional arguments such as reverse. Okay, key reverse length. So key reverse length, you can define a function called reverse length using minus length. Then you prefer equivalent to this one, you do reverse equal true. Okay, so this is another way you can do it using different callback to mimic the function of reverse parameter. Functional chaining. Okay, chaining is simply being able to add another function to the result of another function. Okay, so this is called chaining. Okay, chaining. So chaining means f function result, you will return an object, and that object will call another function, and that one will call another function. It's called chaining. Okay, it's called chaining. So here we have a outer function, and has an inner function. So inner function is a return function. So basically, outer function is a function that will return inner function. Okay. So our outer function, when you call, you will provide outer function. So we will actually do this one. So here, when we run outer function, it will create what? You will return the inner function. So it becomes this outer function, you become inner. Inner will call, so it will call. So the call is here. You call here, okay, and eventually you call this function, and you get this one, okay. It's called chaining. Okay, chaining. So here, what's going on in the example, line 2 to 3, outer function define a local function called inner function. Okay, so that function, that inner function will be the return value for outer function. So whenever you run that outer function, and it will return the inner function for you. Okay, so that's chaining. And you can also use a lambda expression for it. Okay. Lambda expression. So lambda expression can be considered as the anonymous function, and functional programming is about calling function and passing function around. So lambda expression is considered to be the anonymous function, and it is very useful. So you can apply it in many locations. So the syntax of lambda expression is lambda parameter list and expression. So this expression will give some value. So basically, it's similar to define a function f with parameter a, b, and then you do return right away, return the expression. So right here, this one is the expression over here. The parameter list is here, and the name is anonymous. So basically, it is an anonymous function that access some parameter and return the expression right away. That's the feature of the lambda expression. So lambda expression, the keyword that introduces a lambda expression is lambda, and then there's a parameter list, and then there's a punctuation, that's a column, separate the parameter list from expression, and there's an expression. So this table summarizes parts of the lambda expression, okay? And lambda expression is simple. You can have a lambda accepting one, this one is one string, and this one string using the reverse order, okay, starting from 0 to the end. So this one, it is a callable. When you evaluate, it's callable, and it will be doing the so-called reverse, okay, reverse of the data. So the built-in function called callable, you'll return true if the argument is a callable object, false if it is not, okay? And this one is a slicing function that return the character in reverse order, okay? That's that. And okay, here we have a lambda equals this would be equal reverse. So you can assign another function to a reference called reverse, and reverse become the name of the function. So you can call it with the parameter, and that will pass it to this S, okay? And that's lambda expression. So we do have a reverse function that is similar to it, okay? The parameter here. So this one is anonymous. So you write down lambda and then S and then the expression over here, okay? And that's the way you write your lambda expression. Okay, so here, lambda expression is here. It is a callable, so you can call this one with the value here. So that parenthesis make it a callable function. And it's anonymous function, so you can call it at any location you like. Okay, so this one is a lambda expression, and it will return this value divided by this, and the 3 value 9, 6 being put in, and you got the sum is actually 12 plus 9, that's 23, divided by 3, so you get, this one is 12 plus 9, that's 21, so 21 divided by 3, you got 7, okay? So this same thing, you actually get this 3 and then divide by 3 is the sum of this divided by 3. So you have 2.5, 3.0 divided by 3, you get 1.0. Okay, so here you have an animal and you can apply it to the sorted. Okay, this one we see before. Okay, if you use minus as a lambda expression, okay. So lambda expression can also be a return value, and when you try to generate a function, you can also use it as a return value. Okay, so you can return these things and found 3, you pass 3 into there, you return this 3 tuple. Okay, and you can use lambda expression to return a tuple of these and 3 value. Okay, and then X is not defined. X is not defined. Okay, tuple is not defined. You pass X to there. Okay. In implicit packing is not okay. So you have to use parentheses. Okay, you have to use parentheses to make it a tuple. Okay, so you cannot use this one to return 3 part. Okay. So namespace for lambda expression. Lambda expression has its own local namespace. So a parameter name does not conflict with the identical name in the global namespace. So lambda expression can access variable or global space, and it cannot modify it. Okay. So basically right here, okay, let's see. We have lambda S, okay, lambda S and S equal this one. It is a parameter, okay? So you cannot modify the S outside, okay? And you can use lambda as literal. So right here, let's actually look at the function in different way, okay? Let's bring up our chapter 7 demo. So first thing, let's look at the functions. The functions. So to have a summary, we do have a function. We can define a function that takes an x, and then you will return x squared. Okay, that's actually a function. So here we can print f, okay, of 4. That's actually a calculate a square value of for 4. Okay, and that's wrong. Okay, that's one way we can do it. Now another way we can use another function. So we do have g function equals lambda, okay, x, and then x times x, okay. So this one is a lambda expression, and we assign the lambda expression to g. So g is a reference for lambda expression. So here we can assign g of 4 for it, okay. And this one, that's wrong. So we get 16 on this one as well. Then we can have another one that actually is class, okay. This one called H class, okay. And we do not have init, and we do have define, okay. Call, okay. Call function and self, okay, and give it a x, okay. And this one will return, okay, x times x, okay. So here we create a h function, okay. H function, we create h function. We create h111 function, okay. We create a h function, and we call we actually assign to h1, okay. So h1 function, we use this one, okay, and that actually is construct a object of h type, okay, assigned to h1. So here we do print, okay, the h1 of board, okay. So this one it do show you, okay, the three values are the same, okay. So the first one is normal function, okay. Second one is anonymous function. Anonymous function, we call it lambda expression. Okay. Third one is callable class, callable object. Okay, also called function closure. So you make an object, and that object is callable, and you can call it. Okay, you can call it. So right here, let's do print. Okay, callable. Okay, of f. Okay, and we check callable of f. Okay, we check callable of f. We check callable of g, and we also check callable of the h1. Okay. Okay, true. So these three, they are all true. Okay, so you can build a function by default function definition way. You can build a function by lambda expression. You can also build a function by using object and then make it callable. So last one, the callable object, you still can have constructor, you can still have many parameter. So the callable object is more advanced structure, and it allows the most way to configure the function. Okay, a lambda expression is only a lambda expression, and it returns the result for expression. So it's a simplest way of designing a function. Okay, and normal function is in between. The complexity is in between. So these are three ways of defining a function. And let's try different thing. Okay, so here let's try function 2.py. Okay, function 2.py. So here we can have define a function. Okay, this one will take n. Okay, this one will take n, and then they will define an inner function called g function. This one will take x. Okay, and then we will return g function. Okay, we return g function, and g function will actually do return. Okay, you will actually return f function. Okay, actually what f function. So here you will return actually n plus x. Okay, n plus x. Okay, so now f function is a function factory. You make a function, okay, you return a function, okay, and that function will add this. Okay, so here we can do add 2, okay, add 2 equals f of 2, okay. So basically this one will return a function, g function, and that g function will take x, and that x will plus 2 plus x. Okay, you'll return this one. Okay, so this one we will get this, and we do print at 2 of 3. Okay, print at 2 of 3. So this one we save and we run it, and we get a file. Okay, we get a file. So this one is a traditional function but design it as a function factory. Okay. Second one, we may have a lambda expression. So lambda expression n. Okay, this n, it will return another function, return value. So this one we have another lambda expression. This one would take x. Okay, and you return n plus x. Okay. And this one, the whole thing, we will return to a function called g function. Okay, so here, this one is a g function. So we have plus 2 equals g of 2. G of 2, you pass the n2 into here, and you qualify this one, that is your g of 2. And right here, we have plus 2, and we put our plus 2 of 3. And we save all, and we run it. We got another 5 here. So these two functions are actually the same. Okay, compared to the first one we actually a pure function that take data in, data out. Okay, second one we take data in, we return function. That's a function factory. Okay, so now this one we do have another one. That's a class, okay, class, okay. This one that's called actually H class. So this H class would define init function, okay. And then here we have self, and we take n in, okay. And then we do self that n equals n, okay. And then we do define call function, okay. Here we do have self function, and then we take the x into here, and then we return, okay, the self that n plus x, we return it, okay. So here we do have increase 2, okay, increase 2, it will be equals h of 2. So we pass a 2 to here, and okay, and we are going to call it. Okay, this one is object, so we do print. Okay, increase 2 of 3. So this one, it is a function using class design, and we run it, and we get 555. And the last one is a function closure, and in the middle we have lambda expression. On top we have function as factory, and these three actually just perform exactly in the same way. So something like this is what we are going to study in our functional programming. And right here, I show you 3 ways of writing a simple function, and also 3 ways to write the function factory. And let's go back to our first talk in this chapter. When we start this chapter, we do have a table. That take in vector and generate vector. This one is function 1, regular function 1. Okay. Here, second one, we do take vector and we generation. So that's a function. No, we take the number in. So this one is the second example. Okay, it's a second example. And okay, so the second example is actually the function 2 is functional. Okay, we actually it's not function factory. Function factory should take the function in and generate the. I'm sorry, take the vector in. Oh, I'm sorry. I'm sorry. Actually, it's correct. We do take the vector. The vector is n. Okay, we do take n. Okay, we do take n in, and we generate a function called add2. Okay, add2 is a function. Okay, add2 is a function. Okay, and sometimes you can take function in and output some vector. Okay, that's actually try this one. Okay, try this one. Try this one using function input and then generate vector. Okay, so let's try this one. So let's try function 3. So function 3 right here. Okay. Okay, this one should have a S. So let me actually rename it. So functions S3. Okay, let me use this name. So function x3, okay. So right here, let's define a function called plus, okay. So this is a plus function. Right here we have a function, so we'll take x, okay, we'll take x, and then we will actually take x and plus with x, okay. This one actually, let's do this one, and we will return some value, okay, we'll return some value. So this one, you take x, okay, and here let's actually take the n and x in, and you will return n plus x, okay. This one is a function, this one is a function. So here we define another function as f function, okay, you take n in, okay, and we will return, this one is a vector input, okay. I'm sorry, here we do have a function. So this one, let's do function, okay, function. And we are going to, let me see, we take a function input, okay, and we are going to generate function, actually, let's see, one moment, okay. So this one, we are going to take the function as input, and we are going to provide vector, so function as input, okay, and then provide vector as output, okay. Vector as output, okay. So here, we do have a function, okay. We take a function in, okay. We take a function in, and then this function input, we are going to provide value, okay. We are going to provide value. So basically, we define a g, okay, g that take a x in, okay. Take an n in, okay. Take an n in, and then we will return g of, okay, g of actually g of some value, okay. So here, let's see. We will, so this one g will actually return the function, okay, function passing the n, and here this guy actually, let's see, okay, let's see. Here we will return a function, okay. Here we will return a function that will take a parameter, and eventually you will return some value, okay. You return some value. So you will take vector some value as output, okay, some value as output. So you take some value n, okay, and you call a function with n and x, okay. So here we do take a function as input, and we also take a x over here, okay. Let me see. Let's see, here we have a function, okay, I'm sorry. So this one we have a function, and this one we have a, let's see, let's don't decide this one yet, okay. So this one you would take a x, so right here, let's actually do another one, define a h function. This one takes an x in, okay. And g will actually call a function of the n plus x, okay, the n plus x. And we will actually, this one, that's h function, okay, that's h function. So this one, h will return this one, okay, and then g of n will return, okay, h, okay, h, okay, and right here we do return this one, g of n, okay, g of n will return g, okay, will return g for the function, and function g is taking in a number n, okay, and then h function will process with some value. So here, let's do this one, okay, so plus 2 function equals f of plus function, okay, this one, you return a g function, and g function take n, okay. So this one, this guy, let's take a 2 to there, and that become plus function with 2, and this guy will return the h function that will return h function. So right here, let's do print, okay, plus 2 of the 3. And that one, we actually run it, and it get 5. Okay, it get 5. So h function will return, this one will return h function, this one will return g function. Okay, this one will return g, but h function eventually will evaluate the value. This one will provide a value. Okay, at the very end, you provide a value. So you make a function. So here, f function will generate a function. Okay, so this one make a plus 2 function. Okay, makes a plus 2 function. Okay, and then that plus 2 function actually will return a function using plus and 2 with some value. Okay, that's making the plus 2 function using this one. Okay, this one is a using input as input vector. Okay, input a function as input. Okay, and vector as output. Okay, so basically we take the function as input. Okay, and then we return the data. Okay, we return the data. So this one is the functional. Okay, it's functional. So this is plus 2. Okay. So right here we have another one. This one called let's see. Okay, let me use the same naming condition. Okay, so here we have add2. So let me go back to okay. So here let me actually call this one add2. Okay, let me call this one add2. Okay, let me be consistent. Okay, you'll get 5. Okay, you'll get 5. Now the next one we do use lambda. Okay, lambda we do have this one called lambda. Okay, this lambda we take a function value, and then we have another lambda, and you take the n value, and then the inner one is h1. So we take lambda. We take the x value, and we are going to return function, okay, calling n and x. Okay, and this whole scene we do make it what? The plus 2 function will be this one, and we are going to print plus 2, okay, of 3. Okay, so here we actually try using the functional. Okay, second example is function factory. Now we use a functional, and we have a lambda expression. We get this one. Okay, sorry, that's a lambda value, and then we do have, oh, that's a plus 2. Okay, so that's a plus 2. So plus 2, we actually need to put in. Okay, that's actually let's do make plus. Okay, make plus. Okay. So here, let's see, we do have make plus. So we do have plus 2 equals make plus of the plus. Okay, and then with 2 in there. Okay, and then we do plus 2 with 3. Okay, that's the way we do it. Okay, that's 5 pi. Okay, that's 5 pi. So make plus is the lambda. Okay, is this lambda? So make plus, and then you pass a 2 to there. It actually is calling this one. Okay, make plus is the return of this one is a lambda this. Okay, you return this one, and you use 2. Okay, that's actually the function. Okay, it's a functional example of function. So one we're going to try this one called class. Okay, class. Okay, so define. Okay, define init. Okay, and we do put in self and then function and then n. Okay, so we self that function equals 1, okay, and we do have cell.n equals n, okay, we do define callable, okay, and cell and s, and do return the cell function, okay, passing the so-called n and s to it. Okay, this n should be n, okay. So here we do have h of the plus 2 assigned to increase 2 equals this guy. And we do print our increase 2 of 3, okay? And this is the third one we actually use the call functional, and this 3 of print now 555. So this one and the function 2 and the functions, they are doing similar stuff, okay? Yes, doing similar stuff. So here we do show you function S here, okay? Function S2 is the function factory. Function S3 is functional, okay? And we can, this is a function operator, we do see you when we do solve it when it actually is what? The so-called partial function, okay? So the partial function. So let's try this one in function 4. So function 4, we do have define function f that take in func n and actually x. Okay, we take this one and we will return a function of n and x. Okay, and this function that's define the function plus that actually take in n and x, and you will return n plus x. Okay, you return n plus x. Okay, so right here we do have, okay, plus 2 equals, okay, plus 2. That here we do define here we do define a function that actually called plus 2. It take a function, okay, and this guy will return a function of plus, okay, and 2, okay, let's see, and here you should have another variable x, okay, and you pass this one to it, okay, let's call plus 2, okay, let's call plus 2, let's call this guy plus x, okay, plus x, okay, plus x, okay, and then plus 2, okay, will be plus, let me see. Here we do have a plus x, okay, that will put in 2 values to it, and will deal with x, okay. So here we do define plus 2, taking a single parameter x, and it is going to return, this one will be plus x of, actually, plus x of the plus, okay, and x, okay. So here we do have print plus 2 of the 3 using the partial function, and this one get 5, okay. But this one actually is just trying to demonstrate the last example we want to have, that is the function operator, but that it carries some real meaning. I don't think so. It actually, it's too complicated. So I'm not going to try the lambda or trying the callable for this one, okay? Just to demonstrate you that how this function can be operated as parameter, as return value, as assignment, okay? Just to do that, okay? So we are going to continue to look into the map function, the filter function, and the reduce function. Section 7, map function. Applying function to an iterable. So basically, sometimes we can do this one. We can map a certain function to different elements one by one. So basically applying it one by one. So basically, map function by itself has a feature of parallelizing the process. Okay, parallelizing the process. And we have the map, filter, and reduce, this different one. Okay, that reduce no longer in part of the core language, not in the built-in, but we do have a functional tool, like including the reduce and partial. Okay, we do see that before, but okay, so these are functions, take function as part of this input. Okay, so this one is a higher order function. So the first function is called map, okay, which is functions, Python's built-in function. With map, you can apply a function to its elements, okay, and using the function. So basically, you can map a function with an iterable, okay, and you generate another iterable as its return value, okay. So let's try this one, okay. Let me keep this one on the side, okay, and let me get this one. So here, let's create something called map1.py. So here, let's assume that we have a function, this one called a define function plus 2, and you get x, and this one will actually get return, okay, 2 plus x. Okay, this is the function. So we do say x equals 1, 2, 3, okay, and then we do use y equals map, okay, the function plus 2 with the x, okay, then we do actually print your x and print your y, okay. So as you can see right here, this map is a good tool, okay. It's a good tool that actually we can use in many situations. So let's actually do this one. This is a map object. So how about this one? We get a map object and we actually do convert the output to a list. Okay, how about this? We convert it to a list. And let's actually run it. And we got 3, 4, 5. Okay. So that is a simple map function. So let's try another one. Let's try another one called map2.py. So this one, let's try to from PyLab, okay, import star, okay. So this one, okay, I'm sorry, from PyLab, okay, import star. Okay, sorry, I lost the data last time. So now I do import my numpy p, okay. So my x equals numpy that linear space of the 0 to 10 and then 11 point, and I do have my y equals list of, okay, let's don't use this, let's call it numpy that array of this one called function is called numpy that no, let's do lambda, okay, x and return x squared, and then let's put x into there, okay. So see, this one's lambda expression, this is x, and I do put an x. These two x are not related, so let's do figure, okay, and do show and put plot my x versus y, okay, in blue color, okay. Let's see how this one works. Okay. Data type not understood. Okay, let's see. Type error. Oh, okay. I'm sorry. This one is numpy, so we do need to have mapping the lambda to x. Okay, and we get the data, and then we actually convert it to numpy array. Okay. One more time. Oh, they're not supposed to generate. Okay, no, let's don't do it. Okay, let's use list. Okay. Okay, so that gives us this chart. Okay, so basically mapping, you can use it in numerical package. It's quite simply that you create an X domain, you actually map that function to it. So basically this one is f of x, put the f of x here and x here, and you map to it here, you got an f of x. Okay, so that's the use of map function, and very intuitively, you can use it into this numerical calculation. Okay, so that's the map function, and it's very intuitive. Okay. Okay, so here I do not go into the detail of different map function. Okay, I do not go into the detail of this different map function. Okay, so this one, because we can, they are these example are longer. Okay, and you can make it this. Okay, let's try this. Okay, let me actually still go through the slices. Okay, let me still go through the slices. Sorry for that. Okay, let me still go through the slices. So here we do have this map function, and you apply it to reverse to the animals. Okay, and you get a map object, and the map object can convert it to list. Okay, so it's an iterator, and you can print it one by one. Okay, so that we know. So we have an animal, and then you do reverse of the string, and then apply to each of the animal, and then you got iterator, you convert it to list. Okay, so that's that. And here we apply this one to a list. Okay, and we make a list. So iterable item that's not suitable for specification of a function, then you get an exception. So in this case, lambda function expect a string vector which try to slice. Okay, try to slice. The second element is so here this one, there is an element that's with different type. You cannot use lambda for it, so actually you got an exception. Okay, now we got an error exception. So mapping, you must make sure the data is correct. Okay, so here you can press, and then you join this one together. Okay, and this one is join. If you use join, but if you join integer, that cannot. Okay, the data type, wrong data type. Okay, so append this one. Okay, we can use join to append them. Okay, so join, we map this one to string. So basically, we can convert it to string for each one of them, and then prepare them for join. Okay, that actually is okay. So that one is the function of using map. Okay. Okay, this one we map the function of sum to it. Okay, f is sum, and then we make a list. Okay, so that's that. Next function is filter. Okay, so filter, you kind of have a function, and this function is a filter. So function f will apply to each element. Okay, so basically it is a function, Boolean function, and when it is true, the item will be picked. Okay, the item will be picked. So here, let's see. greater than 100. So we have s greater than 100. So this different scene, we keep anything greater than 100. Okay. So we can apply greater than 100 to this one. We do filtering. We get this. Okay. And then we can have a range number and check it if even. It will pick out the even number for it. Okay. So let's try. Okay, let's try this. Okay, let's try this. Okay. Let's try this. Okay. So basically, let's see. Let's assume that we do have a. This one we'll try to use filter. Okay. But let's call it filter one that you want. Okay, filter one. Okay. How about this? Let me actually grab here. Let's grab from internet. It's called function programming. Okay. This one functional programming. I do not need too much. So how about this sentence paragraph here? Okay. Let me put it over here. Okay. It is a paragraph, and I'm going to call it S string is equals this guy. Okay. A string is equal to this guy, and I get a string from internet, right? We're talking about functional programming, okay? So right here, I'm going to actually do this one. I'm going to map, okay, I'm going to map this one, okay, let's see. Let's do list of the S, okay, we convert it to list, okay? So this one will create something called S list. So the S list convert the whole thing to a list, okay? And this one I'm going to map, okay? I'm going to use a filter, okay? Filter of okay is alpha, okay? We apply its alpha function, okay, to this S list, okay? So let's see, okay, let me see, alpha function. Let me see, one moment, okay? So Python is later, okay? Python check is later, okay? For string is lower, this is upper, okay? This is alpha function, but it actually it's actually object oriented, okay? So here we cannot use this is alpha, but we do. It is okay that actually we can do this, okay? We can define a function. So here we do define a function alpha, okay? Alpha give me any character, okay? And I'll return C that is alpha. Okay, I'm going to put this one to there, okay? Call is alpha, and then I'll filter that one out. And this whole thing, when I filter it out, I convert it to a list. Okay. And convert it to a list. When I convert it to a list, I'm going to do, okay, that join. I'm going to join this list. I'm going to join it with a period. Okay. And this whole thing will be SX, will be this one. Okay. And I'm going to actually pull in my SX. Okay. So see EINCON okay, so every character being picked out, only is alpha be picked out, no number, no punctuation mark, nothing else, okay? So here if I put empty string, symbol, it will be a string of letters being created, okay? It will be string of data being created. So basically, I apply the alpha function to each of the letter in the list that coming from the string, okay? and then I apply and I join them together. Okay, and I join them together. So this is the use of filter function. Okay, use of filter function. Next one we're going to look into the reduce function. Okay, so reduce function. A reduce function reducing an iterable to a single value which reduce. Okay, so reduce applies a function to its item in an iterable 2 at a time, progressively combining them to produce a single result. Okay, reduce was once a built-in function in Python. Guido van Rosen apparently rather disliked reduce function and advocated for its removal from the language entirely. Here's what he has to say about it. Okay, he doesn't like reduce. Reduce actually is doing aggregated, okay, aggregated function. So you do one by one to make them together, okay? So that actually is reduce, okay? So same thing, let's actually copy from this guy here, okay? So let's actually copy this one from my filter, okay? And then I'm going to put it into reduce one.py, okay? So I'm going to put it over here, okay? First thing is I need to do import, okay? Functions, function tools, okay? As fn, okay, as fn. So here now, we're going to rewrite it, okay? So there's a string s, okay, this is a string s, and we do have s list equals list of the s, okay? So we convert it into a list. So each one is a character, and we are going to reduce, okay? We are going to reduce. So this time we are going to use plus sign. So let's do reduce, okay? So this is fn.reduce, okay, a plus sign and then using for s list, okay? So plus sign is not a function. Plus sign is not a function. So we do define plus, and then here we have A and B. So two characters, and we are going to return A plus B. Okay, so here we do plus. There's a plus operator, okay? And this whole thing, we will generate it to SX, okay? And we do pull in the SX, okay? So this one is concatenation. It's similar to join function, okay? It is similar to join function. It is similar to join function, okay? You do plus it, okay? You do plus it, okay? Adding one by one, okay? Adding one by one to it. So that one is the reduce function, okay? So this one, sometimes you use it for aggregation, okay? Sometimes you actually run it for aggregation, especially taking sum, okay? Taking sum, you can reduce that into a single value, okay? The result will be fed into the next function call, okay? The result will be fed into next function call, okay? That's called reduce function. Okay, this one, actually, let's try a different one. Let's try reduce 2. Okay, this reduce 2 function is, we do have a define function, okay, define, we do have f function that provide a function f, okay, and we define a g function, okay, g function. So g function will take an x, and we are going to return, this one we're going to return g function, okay, return g function. So g function is a real function that you would take an x and do operation. But this one, we would have this function, okay, applying on the previous result, okay, previous result. So previous result you will get is, you will get a S sum, okay, you get a sum. So here you will do f function. Okay, you do f function. This one, let's see, f function, you do function, okay, and then you do x plus x, okay, you do x plus x, and that one is the value we are going to return, okay, and then you will get this, okay, you get this, that's the function you return. So let's do this one here, let's do I plus, you have A and B, okay, return your A plus B, so that's the function, okay. And then right here, we have a function, okay, we have function and you take S, okay, you take X. So here let's do initial function is called connect, okay. So connect function is f function with plus function, and then it actually provide empty string, okay. So you start with empty string and it's a G function, you take X, and that will apply your function. That function is a plus function, okay. Plus function will connect the current S with the next one. So that's my connect. So next one I'm going to connect, okay, connect 1, 2, 3, 4, 5, right? And I'm going to get this one called X, okay? And I'm going to print X, okay? Must not be integer, okay? Must be string. Oh, okay, here is a string. Here is a string. So that's actually put a 0 here, okay? Is 0 here. It get a function, so connect, eventually it get a function call, okay, get a function call. It get a function call, so that is a function. That is a function, connect by itself. Every time you will get a function, so right here, that's actually to, every time you call it, that's actually print your S, okay, print your S, okay. So right here, let's do this one. So 0, 1, 3, up to 15, okay, up to 15. Okay, that you will print it, okay. So you can use a global function to take it out and take the value, okay, to take the value, okay, so with that. So here, let's do here with this one, let's actually here, let's do this one, okay. Let's see, let's actually get another function, okay. So here, let's get another function, so define H function that will take a function, okay, take a function, and then this whole thing, let me put it over here, that has the result, okay, it will equal 0, and right here, and my result will be, my result here will be equals S plus X, okay, it will be equal S plus X, okay. So right here, I can return, okay, you will return, okay, this one you return R, okay, you return R, okay. So right here, I'm going to do this one. Right here, I'm going to do this one. Let's do this one is another wrapper, okay. This one is another wrapper. So we can, this one is another wrapper, okay. So this one is another wrapper. We can get this one and get R. And here we can put the calculation here. Okay, we can put the different calculation here, so we can push this different thing over. Okay, over here. Okay. So we kind of get this. Okay, we kind of get this, and it will return R. Okay, so right here we are going to do H of what plus function. Okay, we do H of plus function. Now we do the connect everything. Okay, it will actually connect everything. Okay, so save. That's wrong. Okay. It is 0. I'm sorry, it's 0. So here that's actually this R is a local variable. So this one actually non-local R. Okay, this one non-local R. It got 15. Okay, it got 15. Okay, so this one is showing you some sort of reduce. Okay, some sort of reduce. This function is a little bit complicated. Okay, and a simpler version. That's this one. Okay, I put into reduce 2. So here, let me create another one for reduce 3. Okay, reduce 3.py. Okay, so let me put that function into here. Okay, and let me keep the original version of the connect. So that's don't have this. Don't have this. Okay, just have the f function. So let me keep the f function here. Okay, and g function over here. Okay, and do not collect the r. Okay, do not collect the r. Okay, R is only to actually show you how you collect the data. Okay, how you collect the data. And this 2, let's put it here. Okay. And the define function, let's actually cut it. Okay, and put it over here. Okay, put it over here. Okay, so that the connect will do it every time. So here, let's every time let's do fluid. Okay, this plus x. Okay, that's a value we got every time. Okay, so we connect everything and we set all and we run, and we got the sequence of these. Okay, we got the sequence of these. Okay, we got the sequence of these. Okay, we got a sequence of that. And here, if you like, you can also have the R. Okay, and R equals 0. Okay, and here you can have a global. Okay, and the global R equals x plus x. Okay, the return value. And right here, you do pull in your global R. Okay, so that's that. Showing you the chaining function and how to get the value. Okay, that's another kind of reduce. Okay, using the chaining function. A lambda expression, you can put it to reduce. Okay, so you basically every time deal with 2 numbers. That's the way you use for the reduce. Okay, and usually you have the so-called accumulator. Okay, in the so-called accumulator to accumulate the result of the everything. Okay, that's called reduce function. Reduce some function sometimes very useful. Okay, so right here, let's actually try another one called reduce 4. Okay. So here we do define. Okay, connect. Okay, connect A, and we do have this one called return plus B. Okay, and we do reduce. Okay. To connect. Okay, connect with. Here we do have S equals A E I O U, and we do list for S, put it into S list. Equal this one, okay. And here we put S list, okay. Put this one into S list. And we do not have reduce, so we need to do import, okay. Function tools, okay. Fn, okay. And this one we do call fn.reduce, and you will get some value, and that one is our data, okay. And at the end we print out our data. At the end we print out our data, okay. So let's save all, and let's run. The data is AEIOU. Okay, data is AEIOU. So let's try another one. Let's try have a data A equals 1, 2, 3, 4, 5. Okay. And then we do data 2 equals function. Okay. A, okay, and then we print out my data 2, okay, print out my data 2. Okay, we get 15, okay, get 15. So these are very interesting experiment using reduce, okay, and in NumPy array, there is a function called any. NumPy array is any function, okay, so there's any function. So let's look at the NumPy array any function. So NumPy array any function, A is array like data, okay, and you do what? You do out. Out is ND array, okay. It's an output array, okay. It's an output array, and then there's a keep dimension, yes or no, okay. There's keep dimension. So there's an output array and where equals something, okay. Where equals something. So where equals array type of Boolean, okay. So C reduce, so it's actually reduced, okay. So let's try this one, okay. Let's try this one called numpy.any, okay, numpy.any. So this one is called reduce number 5, okay, reduce number 5. So here let's do import, okay, numpy SNP, okay, SNP. So our data A equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And this whole thing I actually converted to numpy.array. So I have a numpy.array like this one, and I do run numpy.any of the A, okay, where equals, okay, where equals numpy.any, A is array, okay, keep dimension, okay, then there will be a output, let's try B, okay, B, okay, so B is the output, so let's do B equals empty list, okay, numpy.arrays of empty list, okay, empty list. That's actually B. So where things is actually, let's do this one. Let's do the data, okay. We use what? This one, the S is, okay, where equals false true. Okay, I'll actually array false. Okay, so here we do this, okay. Here we do array of true and array of false. Okay, array of false. Let me see, okay, array of true and array of false. We have the numpy of any, okay, these are true and false. And where, okay, where. Here we have a where equals this, okay. where function, okay. This one, actually, let me see. This is not a good example, okay. So let's try another one, numpy.any. So numpy.any is brand, okay. So numpy.any is brand. So here, let's see. This is, okay, numpy.any. Numpy the test if elements are true, okay. If this anyone is true, it will be true, okay. Anyone is true, that will be true, okay. Test the element of array element. If it's true, it will be true, okay. Number of the any that's true is true. So my array greater than 2, okay. Any of my array greater than 2. So that's this one. Let's don't do this, okay. So numpy, this one give you, okay. Actually, let's do 3 in A, okay. So this one, let's do result, okay. So we do not need this, okay. So 3 in A is a Boolean test, okay. It's a Boolean test. And it's true, okay. 3 in A is true. So let's try this one, okay. So here actually we do have A, okay. So here actually any of A, okay, any of A greater than 10. Okay, let's try this one. So it's false, okay. Any of A greater than 5. Okay, that's true. So it's very easy that you use this one to check if there are some data of certain property using this one. It's similar to reduce, okay? Similar to reduce. So when you look at this one, when you refer to, it also say reduce for detail, okay? You also say reduce for detail. So that is the function of the of it, okay? That's a function of reduce, okay? So here you can implement the map function in terms of reduce. So you basically, this one is custom reduce. You do reduce and then using a lambda function, and then that lambda function apply to iterable, okay? And to an empty array, okay? So basically you custom map, okay, custom map function, okay, to iterable. So there's a string function being applied to each of the value, and each of the value will be concatenated with the previous item, okay. And then initially you are going to, it is appending starting from empty list, trying to append in every data into the list, and eventually you get 1, 2, 3, 4, 5. Okay, get one data, make a string, and then so this one using is actually custom map. Okay, using reduce to do custom mapping, and that's another way to do it. Okay, so reduce and any and the map sometimes you can use one of them to write the other one, rewrite the other one's function, okay? Rewrite the other one's function, okay? So functional program is a programming paradigm in which the primary method of computation is evaluation of pure functions. Although Python is not primarily a functional language, it's good to be familiar with lambda, map, filter, and reduce because they can help you write concise, high-level, parallelable code. You also see them in the code that others have written, okay? In this teacher, you learn what functional programming is. how functions in Python are first-class citizens and how that makes them suitable for functional programming, and how to define simple anonymous function with lambda, okay? And how to implement map filter, implement functional code with map filter and reduce, okay? So basically we teach you how to use this map filter reduce, and also teach you the key idea of functional programming, especially how to use function to generate different things. Okay, thank you. That's it for today.